Okay, so that is the latest version of the syllabus. We are right here on Wednesday, second meeting week number 1. I'm going to cover a little bit of the electric force for the first hour. And then for the rest of the class, I will talk about the spreadsheets that you're going to use for the lab. Okay, let's take a look here. Okay, that's insert page break. Today is February 11, 2026. That's Wednesday. We'll cover the electric force for the first hour, and then we will divide you in groups and just revise a little bit how to plot, right? How to plot in Excel, since there are some of you didn't, most of you, right, didn't take my physics 6 course. So I think we could do that. We could do that. This one goes here. One more student joining us. And it's just to remind you, right, what we did before, the 3 building blocks of physics. The new building block, the new quantity that we are covering is the electric charge. And we will be covering the 4 laws of electromagnetism. The first law is the Coulomb's law. And the Coulomb's law is exactly that law of the electric force that we saw before. You have to memorize that, okay? Here you go. Here's the equation for the electric force. The magnitude of the force is given by this relationship. Now, Coulomb's law. Coulomb's law has more than one format. The first law of electricity and magnetism. Go. That's whenever you have 2 charged particles, one next to each other, nearby each other, exert a force. The force can be either attractive or repulsive. The electric force, unlike the force of gravity, the electric force can be either attractive or repulsive. You know, just compare that equation with the equation for universal gravitation. It's very similar in mathematical form, the mathematical format of this force. Even though there is some critical differences, the equation is very similar. Okay, this equation, the equation is very similar to the equation of the universal law of gravitation. Okay, universal law of gravitation. Whenever you have mass 1 and mass 2, you got mass 1 and mass 2. All we have to do here is replace the constant k that. Am I sharing? Am I sharing the screen? Yes, right?
Yes, you are.
Yes, Professor.
Okay, good. Thank you. Here you go. You have a big here, big G here, and then instead of charge 1 and charge 2, you have mass 1 and mass 2. Okay? And the distance is in D here is the distance between the masses. So, equation-wise is very similar, but then there are very important differences between those two equations. It's amazing, right? How those two laws that describe two completely different phenomena can be so alike. Okay, it is really surprising, right? Let's write it like that. Surprising that two independent laws that describe two completely different phenomena can look so alike, so similar, can look so similar. Okay, but then there are very important differences between them. Okay. First of all, between them. Okay, the first difference that I'm going to, the source of the force. Here you go. That's one important difference, the source of the force. And I'm going to put that in a table format, okay? The multiplicative constant, okay? Attractive and repulsive forces, right? One is just attractive force. One is just attractive, the other one is just repulsive. So those are the three main differences that I can. The source of the force. One source is for the, the mass. For the gravitational force, the mass is the source. Here you go. For the gravitational force, the mass is the source of the force. For the electric force, the charge is the source. So you can put it here, mass versus charge. Multiplicative constant. One is the big G versus K. Okay. Gravitational force is only attractive. Electric force is both attractive and repulsive. And there is more, right? Another important difference is that the source, let's go here to put item number 2, right? The source of the force source of the electric force can be either negative or positive, right? Whereas the source of the gravitational force is only positive. There is no negative mass in the universe. At least for the sake of this course, right? At least for the sake of this course. For the sake of this course. If you hear about a negative mass, let me know. for the sake of this course. We never know how physics advance, right? Let's take a look. I think they have discovered a negative mass out there, but I'm not sure. Let's see. Is there a negative mass in the universe? Let's see. Let's see. Negative mass. Wikipedia. Yay! Haha. Wikipedia, right? I love Wikipedia. So, in theoretical physics, negative mass is a hypothetical type of exotic mass whose mass is of opposite sign to the mass of normal matter, minus 1 kilogram, right? So, but we're talking about hypothetic here. But they also mention about exotic matter, okay? Hypothetical particles and states of matter that have not yet been encountered, okay? So yeah, they have not been observed experimentally. Okay, so we are safe to say that negative mass does not exist, but whose properties will be within the realm of mainstream physics if found to exist. Okay, that's would be the type of exotic matter. Let's take a look here at this. Hypothetical state of matter have not yet been encountered. Yeah, okay, several particles whose existence has been experimentally confirmed that are conjectured to be exotic hadrons and within the standard model. Okay, so it looks like they have encountered experimentally, but has not been, has been experimental. It looks like has been experimentally confirmed, right? So, so this bullet here is in conflict with the other bullet. Several particles whose existence has been experimentally confirmed that are conjectured. Okay, that's the important word here. Conjectured. And states of matter that are not commonly encountered, such as bosons and condensates, nuclear matter, quantum spin. Okay. Oh, they're talking about exotic matter. Okay, they're talking about exotic matter, not about negative matter. Hypothetical. There are several proposals. Let's see, negative. Yeah, they're talking about exotic matter, not negative matter, right? Not negative mass. Let's see, negative mass. Here you go. That's the one we want to talk about. Negative mass would possess some strange properties, such as accelerating the direction opposite of the applied force. Despite being inconsistent with the expected behavior of normal matter, negative mass is mathematically consistent and introduces no violation of conservation of momentum or energy. It's used in certain speculative theories, such as the construction of artificial wormholes and the Alcubierre drive. The Alcubierre drive that is the Star Trek drive that's used in the Star Trek TV series, right? There's a name for that. How do they call it? It's let's take a look here. Alcubierre drive. Warp drive. Yeah, that's the word I was trying to remember. Warp drive. Okay, so the closest known real representative of such exotic matter is the region of pseudo-negative pressure density produced by the Casimir effect. Okay, so we are safe to say that at this point, that there is no such thing as negative mass. Okay, but look about that. They also talk about imaginary mass, right? Tachyons are supposedly have an imaginary mass, but tachyons, just like negative mass, has not been observed yet. This is just conjecture. So we are very safe to state that there is no such a thing as negative mass in nature. Attractive. Okay, so those 4 points I want you to remember, and we can construct a table to compare those two theories. Okay, so let's go get a table. Tables are very useful things. Okay, gravitational force. type of force? Force. Gravitational. Electric. Okay. Let's see how we're gonna do that. Source. Source, right? Mass. Source of the gravitational force is the mass. Source of the electric force is the electric charge. Okay, a mass has electric charge. What else? Sign. Sign of the source. Only positive. Positive and negative. Okay, here what are we doing here? We are comparing one type of phenomenon with the other, right? Comparison between gravitational and electric forces. Okay, difference, let's put here differences between gravitational and electric forces. We are going to put, I will boldface here. I'm just translating those four paragraphs here in terms of a table. Sign of the source, only positive. Gravitational, the mass has only a positive sign. Electric charge has both positive and negative signs. Multiplicative constants. Multiplicative constants. The G and the K. And by the way, we can put another line here, units of the constants. Not only, there's another important difference between those two types of forces, right? The units of those constants, of those universal constants. Now let's put here universal constants. Units of the universal constants. Of the universal constants. We can come up with the analysis of this equation to find out what's the unit of the gravitational constant. Okay, the unit of the gravitational constant is completely different from the unit of the electric constant. And they are valued too. They are very different as well. Here you go. Newton meter square over kilogram square. That's the unit of the gravitational constant. Okay, and here we have the unit, a lowercase k, okay? I want to put lowercase k, like that. I'm going to write down what's the numerical value of this constant. And here, the units are quite of similar. Again, N, okay, Newton. Meter square, but instead of kilogram square, it's going to be the Coulomb square. That's the unit of this constant. Can I come up with some other, okay, units of the universal constant? Okay, attractive and repulsive force. Okay, attractive and repulsive. Okay, only attractive. Only attractive. Let's see. Nature of force. Let's see. Nature of the is better. Nature of the force. Only attractive, and then attractive and repulsive. You can write down like that. And now we have our table with the difference between those two laws. Okay. One is, here you go, we can write down law of universal gravitation. right? We can put another one here. Coulomb's law. Coulomb's law. Can write down like that as well. Stretch. Let's see. I want to have this table in a nice format here, so we can use up the space. Here you go. Nope, cannot do better than that. Extend a little bit like that. Yeah, good. No, yo, let's see. Yeah, now we got it. Okay, so that's the difference in table format. 1, 2, 3, 4, 5, 6, right? So you have one more here. Attractive and nature of the force, attractive laws. Units, we gotta put that units of the constant. Nature of the force, laws. Okay, 1, 2, 3, 4, 5, 6. Now let's take a look at the value of this constant. And let's compare. Well, let's compare, right? Numerical value. Let's write it down here. Numerical value. One is very small, the other one is very large. Okay? Numerical value. Numerical value. Numerical value. Numerical. You don't have to memorize those values, but at least you should know that one is much greater than the other. This one here is much greater than the other. Numeric value, okay? Only the numeric value. I'm not talking about the units, okay? We cannot compare two different units, right? But we can compare the numerical value of each unit. And what's the value of this constants? One more student coming. Here go. Let's see here. I don't memorize those things. So I don't require you to memorize. But like I said, at least you must know that one is much greater than the other. Electric force. Here you go. The universal big G is equal to this numerical value times the unit, okay? Note, see that we have a 10 to minus 11 here. And what else? K, let's see, K, what's the value of K? Okay, let's take a look at the internet. I'm not finding here in my notes. Universal electric constant. Electric constant, right? Electric constant. Vacuum permittivity, yeah. No, it's not vacuum permittivity. Vacuum permittivity is the inverse of the other one. Let's see if we have it here. Wikipedia, epsilon naught. Epsilon naught is related to K, okay, folks? Is related to K. Let's look at the different way. Electric force. Coulomb's law, huh? Coulomb's law. Here again, Wikipedia. Coulomb constant. Okay, they call it the Coulomb constant. Now, what is the value of the Coulomb constant? There is a way to measure the Coulomb constant in the lab. They even sell experimental devices for us to find the value of the Coulomb constant. That's the one. Okay. Remember that I told you the permittivity is related to the Coulomb constant. Is the Coulomb constant is the inverse, is inversely related to the vacuum permittivity. So it's approximately 9 times 10 to the 9. That's easy to memorize, right? 9 times 10 to the 9. Just remember that's the number 9. If you just say that 9 times 10 to the 9, you incur in an error of less than 1%. A little bit more than 1%. No, let's see. No, it's much less than 1%. You incur in an error that is 1/10 of a percent, 2/10 of a percent. Okay? If we say that is 9 times 10 to the 9, the error that will be incurring is very small. I'm going to do the math here for you. Wait, 0.987551 minus 9, right? Divided by 8.987551. So multiply by 100. Wow, it's 1/10 of a percent, okay? 1/10 of a percent only. 0.13%. Very small difference if you just, say that 9 times 10 to the 9. Like that. Okay, I'm going to put it approximately 9 times 10 to the positive. I'm going to emphasize as the positive number. Do you see that this numerical value is much larger than this one here? Here's 10 to minus 11, and this is 10 to the 9. Because of this difference, because of this difference in the value of these two constants, because of this difference in the values of these two constants, we say that the electric force reigns supreme in the microscopic world. Every time that you make calculations of charged particles, right? Every time that you perform force calculations, right? Perform force calculations of charged particles in the microscopic world, you can neglect the gravitational forces that they exert among each other. And I'm talking about, don't forget, each other. Okay? I'm talking about charged particles. Okay? Of course, if you put a neutron next to a proton, of course, that the gravitational force is going to be greater than the electric force, right? Since the neutron has zero charge, protons and neutrons do not exert any electric force whatsoever between them, right? Okay, so he go to, okay, charged particles. And that's very important. Here we go. Macroscopic versus macro versus microscopic world. This is a macroscopic force. Macroscopic force. Type of force. Let's put here type of force. Type of force. This is a microscopic force. This is a microscopic force. Electric force reigns supreme in the microscopic world. Units of the constants. Let's put here. Let's do it this way. As time goes by, we find simple ways of improving the table, right? Here you go. Supreme. Okay. We can even make we can even calculate. We can even compare. Here you go. Compare the electric and gravitational forces between a proton and electron. Okay, let's do that. Calculate the numeric values of the electric and gravitational forces between a proton and electron. Also, determine the weight of these two particles, and compare their weight, which is another way of calculating the gravitational force, right? The gravitational force due to the Earth applied to these particles. Let's see, admit all, here you go. Also, determine the weight of these two particles and compare their weight to their gravitational and electric forces. Can you do that? And we gotta put it, let's see what we can do here. Yeah, but we gotta, for the first case, do the following. Here you go. It's two different proposals here. Okay, do the following. One, calculate the numeric value of the electric and gravitational forces between a proton and electron. And two, determine the weight of these two particles, which is the gravitational force due to the Earth, right? Which is the, let's see, would they just cancel each other out since one's negative and no. Are you talking about let's see. Let me answer Jeremy's question first, right? I'm going to upload this document. Yes, Jeremy, I'm going to upload this document later on, right? Since I'm working in real time, I cannot upload it right now, right? But I will upload at the end of the class. Part of this discussion is in the document of the last time that I taught this course, the 2025. Okay. Now Jeremy is also asked, would they just cancel each other? What do you mean they would just cancel each other? Are you talking about the force would just cancel each other? Or the charges would cancel each other, right? You gotta, I want, like the charge. Okay. The net charge is zero. Yes, Jeremy, the net charge is zero, but not the force, right? Not the force. The force is not zero. Okay, but the net charge is zero. See the difference? Okay. Yeah, the net important, it's very common for us to make this, to confuse that, right? So let's go get here. That's the one I want. So here you go. I had this illustration before, right? You have a positive charge and a negative charge, right? Yeah, they do cancel, right? The net charge of this system is zero, yeah. But it doesn't mean that the net force is zero. No, no, no. It doesn't mean that the net force is zero. There will be a force applied to each charge. Let me see. I can say that the net force is zero, yes, but not the force applied to each charge separately, right? See, notice that one force points to the right and the other force points to the left. If you take those two particles as being our system, the net force, yes, would cancel because this force to the right is going to cancel out the force to the left, right? But not the force applied individually in each charge, okay? So that would be a better answer to your question. We can even write that down here. Let's write that down. That's a good question. Huh? Here you go. And here you go. Don't forget, right? I have last year's notes there in Canvas. You can download to your computer, and those notes are not exactly what I'm doing right now because I always change something here and there, right? But it can be helpful for you to follow from the last year's notes. Okay, let me move it to the right, the left. Here you go. I'm going to write down what I just said about okay. If you have, here you go. If you have an electron next to a proton, right? An electron next to a proton, we can state the following. One, the net charge of this system, proton plus electron is zero, okay? But you already know of this system, proton, but of course, the net charge of the electron alone is very important that you start thinking along those lines, okay? Is negative, right? The net charge of the electron alone is negative. The net charge, oh, what happened here? Here you go. The net charge of the proton alone is positive. Positive, okay? Now, what else can we say? The net force of this system, proton plus electron, is zero. Yeah, the net force is zero, but not the separate force, okay? However, the force applied to the electron separately is not zero, right? And the same thing can be said of the proton, okay? However, the force applied to the proton alone, right, or separately, alone, slash separately, is not zero, okay? And then you gotta put a comma right in here, another comma right in here. Here you go. Those are the 6 different. So let's calculate now. Calculate the numeric value of the electric and gravitational force between the proton and the electron, right? Okay, solution. Okay, we can go ahead and pick up the equation. We have 2 equations here. I'm going to use both of them. Here you go. Here is one is the electric force, the other one is the gravitational force. Okay, let's not forget that Q1 and Q2. And since I'm using the magnitude, right, we can use magnitudes here as well. Okay, I can use magnitudes here as well. That would be the correct way of writing this equation. Okay, the force must be positive. So consequently, when you multiply one charge by the other, it must be a positive quantity too. So you must put this magnitude right here. Let me correct that upstairs. Right here. Oops, not this one. Mass is always positive, so you don't have to worry about putting the signs of magnitude there. Okay. And then we have to, let's consider at the distance, calculate the numeric value of the electric and gravitational force between a proton and electron when they are separated by 1 centimeter. Okay? When they're separated, and compare their weight to the gravitational and electric forces calculated in item number 1. Okay? First part. Don't underestimate what we are doing here, okay? It is very important that we have an idea of the numerical value of those forces. So you know when to neglect one force and when not to neglect a force, okay? First part. There are two ways of doing that, okay? You can either substitute 1 centimeter here, or you can take the ratio of those two forces, okay? You can take the ratios of the two forces to see how one compared to the other. And I have to do something else too. I need to put a letter E here to emphasize that this is the electric force. And I'm going to put another letter here, big G, to emphasize the fact that this is the gravitational force, okay? So let's take the ratio of this value and this value. If we take the ratio of them, we don't need to substitute the value for D, right? And let's not forget, here is going to be the mass of the electron, and here is going to be the mass of the proton, right? The mass of the proton, let's put it this way. And then I'm going to change, let's leave it M1 and M2, okay? So I don't have to change my notation here. What I'm going to do, I'm going to divide this by this one and see what's going to be the order of magnitude that we're talking about. If the number is more than 1, right? If we take the ratio between those two, then it means the gravitational force is larger than the electric force, right? But I already told you that the gravitational force at the microscopic level is much smaller than the electric force. Here you go. Gravitational force. Okay, I'm gonna take the ratio, and then we can do also the two charges separated by 1 centimeter, so you have an idea of the type of magnitude in terms of newtons, right? When I take this ratio, I don't have to worry about the distances between the particles, and make it easier for us to have a proportional idea of the relative. Okay, yeah, okay. So Mirage, so we can do, we can solve this thing in two different ways. Okay, this first item. Okay, Mirage. Okay, let me put it here. In this first part, we can solve this problem in two different ways. Okay, two different ways. The simplest one, the most straightforward one. Okay, one. The simplest one and most straightforward one is to obtain the numerical value of each force separately whenever the two particles are separated by 1 centimeter. Did you get that, Mirage? Okay. So let's do this one that is the most straightforward one, and then we do the more complicated one. Okay, let's do this one first. The other method, okay, the other way, you know. Let's see here. Change this level, set numbering value to the other way, which is more generic, right? But more difficult to understand, is by just taking their relative, just taking the ratio of these two forces, okay? The ratio of these two forces. That's what I was doing without the need to include the distance between the charges, okay? But let's do the first one. That's it's simpler and more straightforward to understand, and then we concentrate on the other one. Okay, I'm gonna need my Excel spreadsheet to do that. Okay, here we go. My spreadsheet is right in here. Let's see, roster. P07 roster. Let's see this one. Hopefully that's the one. Yeah, that's the one. That's the one I want. Okay, let's get another spreadsheet here. Electric versus G forces. Okay, electric versus gravitational forces. Okay, so what I'm going to do here, I'm going, instead of using my calculator, okay, I am going to use my spreadsheet. I prefer to use the spreadsheet. What we need? We need the numeric value of K, which has a unit. We need the numeric value of G, which has another unit. We need the numeric value of D, that's going to be in meters. We need what else? We need the value of each charge, right? Protons and electrons, they have exactly the same magnitude. The charge of both particles is exactly the same magnitude. It just happened that one has a negative, the other has a positive. What else do we need? We need, here you go. Coulomb. Okay, now, good. Now he doesn't do it. And then we are going to have the gravitational force, and we're going to have the electric force. In both cases, the unit is going to be a Newton. He's going to be the Newton as well. And I want to subscript. Here you go. Subscript, yeah, the G, and I'm going to subscript the E as well. I I can put the unit there. Let's see, the unit is going to be what? A Newton meter square over Coulomb square, right? That's what the unit is. And superscript. And here's going to be superscript as well. Superscript. That's the unit for K. The unit for G is going to be similar. Okay, that's why I'm copying and paste there. The only difference here is that instead of Coulomb square downstairs, it's going to be kilogram square downstairs. I'm using SI units. Here is easy to memorize, right? This one is what? 9 times 10 to the 9. Right? Very, very good approximation for this constant. The big G is we know that's 10 to minus 11, right? 10 to minus 11. Now, what's the number that goes in front of the 10 to minus 11? The number that goes in front of the 10 to minus 11 is 6.67. 6.67, you go. If they are a centimeter apart, they're going to be 10 to minus apart. 10 to minus 2 meters apart. The charge, you have to remember what's going to be the electric charge, right? The electric charge is going to be 1.61, right? You remember that? 1.61 times 10 what? 10 to minus 9. Let's go back here. We have a table there. Do you see? 10 to minus 19. Okay? 10 to minus 19. 1.6 times 10 to minus 19. Okay? Hey, there's something wrong here. Times. Here you go. Okay. And now we have to write down the formula. Oh, we still have the masses of the particles. Okay, mass of the electron in kilogram, mass of the proton in kilogram as well. Subscript, here you go. Mass of the electron, mass of the proton. Here you go. And mass of the electron is much lower than the mass of the proton. And what's their numerical value is? Let's go back to our notes. Mass of the proton, 1.675 times 10 to minus 27. 1.675. 1.675 10 to minus 27. 10 to minus 27. Uh-oh. Here you go. And I remember I told you that the mass of the electron is 1800 times less than the mass of the proton. 9.3 times 10 to minus 31. Approximately, right? I got, yeah, 10 to minus 31, right? I didn't get exactly the same number, just slightly higher, 9.3, when the true value is 9.11. But in case that you don't remember the exact value of the mass of the electron, but you do know the mass of the proton, you can get a very good approximation by dividing the mass of the proton by 1800, right? Let's put 9.11. 10 times 10 to minus 31. Here you go. 911 times 10 to minus 31. And now we are going to do the actual calculation, right? Gravitational force. Gravitational force is G times mass of one, mass of the other, divided by 1 centimeter square. Okay? That's the magnitude of the force. 10 to minus 63. Okay? This is number newtons, right? Approximately 10 to minus 63, 1.01 times 10 to minus 63. If you go do the same calculation for the electric force, let's see what we get. K, charge of the proton times the charge of the electron divided by the distance between them squared. And look here at those two values. One is 10 to minus 63, the other is 10 to minus 24. How many orders of magnitude greater? Right? Let's do the math here. And here we go. Ratio divided by FG. FG. There is no unit, right? When there is no unit, I write down the number one in between parentheses. Okay? That's what the number one is all about, is to state that the parameter that I'm calculating has no unit whatsoever. Divide one by the other, you're going to find out the force. The electric force is several orders of magnitude greater than the force of gravitation. 10 to plus 39 is such a large number, so large, that we can neglect the gravitational force. Do you see now why we can neglect the gravitational force at the microscopic level? And then we can keep on playing with the numbers. Instead of 1 centimeter, let's make them closer, like 1 millimeter. Let's see what happens. Okay? Notice that this ratio is not changing, right? This ratio is not changing because this ratio does not depend on the distance between the particles. Okay? I'm going to undo, right? 1 centimeter. Here you go. See, it's the same ratio. The force is changed. The value of the force is changed, but not the ratio, because the ratio does not depend on the distance between those two particles. Okay? So the force increased a little bit, right? What about, let's say, 1/10 of 1/10 of a millimeter, right? Here you go. The electric force increased and the gravitational force increased too, because the particles are getting closer and closer to each other. Now, let's see, 10 microns. Now they are 10 microns distance. Here you go. The ratio didn't change again, right? But each separate force changed. What about 1 micron distance? Okay? That's the type of force that you get for those distances, right? And now, what about mg? Let's calculate mg, right? mg, which is the gravitational force that the Earth exerts on each of those particles. Here you go. You're going to see mg. Here you go. G, no, G, lowercase g, right? Don't forget, lowercase g. And I'm gonna do for the electron and for the proton. And that's the second part of that problem. 9.8, right? Meters per second square. Mass of the electron times 9.8. And by the way, it's not kilograms. Here is newtons. Here is newtons as well. Now, I suggest that you will follow what I do here. Okay, in your own spreadsheet. so you know how to work so you become familiar with the Excel, right? Now let's see how do they compare, right? You're convinced, right? Are you convinced that the electric force is much larger than the gravitational force? The gravitational force of attraction, right, between the particles is on the order of 10 to 39, 39 orders of magnitude, 39 orders of magnitude. So when we are doing our calculation, if you're a chemist, for instance, you don't need to calculate. You don't need. You can neglect completely the force of gravitational attraction. Even the weight of those particles is smaller, right? So here you go. The mass of the proton times the acceleration of gravity is 10 orders of magnitude smaller than the electric force. And that's for 1 micron distance, right? Let's put 1 millimeter distance. 1 millimeter distance. Now, 1 millimeter distance, and those electrons they do not get that far apart whatsoever, right? Here is 4 orders of magnitude greater. Oops, did something. Here you go. I'm not supposed to do. Compare, right? The weight of the electron is much smaller than the weight of the proton because the proton is heavier, 2,000 times, 1,800 times heavier, right? So depending on the distance between the proton and the electron, the force, the weight of each particle is going to be larger than the gravitational force, right? So that's what we get, okay? Let's see. Did you get the idea now, folks? Did I convince you that let's put 1 centimeter, right? Because I say 1 centimeter there. And now minus 24 here, minus 26, right? And we are going to compare all those results that we got in a nice table. Okay? Here you go. Here, let's see, that's the other way. First part, and then the second part. Let's see here. I should take, since I did the other ratio there, right? Let's do according to what I did before. M1, M2. Okay. And let's see, should be K here. K here, should be big G here. Big G here, and should be K here. Just put it upstairs. I'm doing that just to be consistent with what I did in the spreadsheet. And we calculate that, and it was a very large number. This ratio was a very large number. 10 to 39. 2 times 10 to 39. 2.29 times 10 to 39. 2.29. 2.29 times 10 to 39 times 10 to 39, like that. What does it mean? It means that the electric force is much larger than the gravitational force. The electric force between those two particles is much larger than the gravitational force and the gravitational force of attraction between those two particles. The second part, here you go. This one I got the electric force. Going back to my spreadsheet. I'm gonna put here on the side. We are about to have our break, right? Gravitational force between them is going to be 1 centimeter distance, right? By 1 centimeter. 2.33 times 10 to minus 24. Here you go. Minus 24 newtons. Don't forget we have a newton here. I'm just gonna copy here and paste here. But it's not the same value, right? It's gonna be a different value. 1.02 times 10 to minus 63 newtons. Okay, and then we have to do the second part. And after doing the second part, I'm gonna put everything in a table. So here you go. The weight of the proton times g, right? I'm gonna put like that, weight of the proton. Yep. Mg 1.67 times 10 to minus 7, 1.675 times 10 to minus 27. Newtons. Okay? Again, I'm going to repeat, right? What you have here is the weight of the proton on the surface of the Earth. What you have here is the force of attraction between the electric force of attraction between the proton and the electron. And here is the gravitational force of attraction between those two particles. Second, okay, here's going to be the electron, and the numeric value is 9.11. 9.11 times 10 to minus 31, like that. Oh, let's not forget, put the units, right? Put the units here. Here you go. And now we're going to do our table. Let's see how it's going to be our table here. Electric force, gravitational force, weight. Yeah, that's how we're going to do it. Okay, let's see. Table, let's see if I can get it right. Okay, electrical force, gravitational force, and weight. Okay. Electron, proton. Yeah, here you go. Maybe you can do that. One more. Huh? Okay, electric force. Gravitational force. I'll have to put those here. And the weight of each particle. Okay. And for D equal to 1 centimeter, right? D equal to 1 centimeter. One more student coming in. 1, 2, 3, here you go. Now let's copy and paste what we had there. Electric force. Gravitational force. Weight of the proton. Weight of the electron. Okay, we don't need those two. Okay. So here are the numerical results. Okay, and again, note C. No, I'm repeating that the electric force is several orders of magnitude greater than the gravitational force of attraction between those two particles. Now, let me take attendance. I'll do that just for the first two weeks. What do you mean by? Mirage is asking me whether are these mandatory to be memorized. What do you mean by these? You know, Mirage. Oh, the whole formulas. Okay, if the test is open notes, open book, you can look at the note at the equations in the book, right? So you, in principle, you don't have to memorize, but it is better. It's best if you do memorize them because you can work more quickly. Okay, you can go faster. You can work faster. Okay. Okay. So let's see. I want to take attendance now. I want to I want to take this chance to separate you into groups, right? And let's start with Mirage. Mirage, do you have? Well, what I do is the following: I ask you if you have anybody in particular that you already know that you'd like to be in your group. Okay, that's what I usually do to my students. If someone that you prefer to work with because you already know that you work well with them, Mirage, do you know anyone in the class that you'd like to work with as a lab in your lab group? Only remember, only 2 students per group. Only 2 students per group. Hello, Mirage. Let's see. I just had to connect with a couple of the students last session, but I think they are all working together. Okay. So at this point in time, you do not know any student that you want to work with, right? That's what I understand. So I'll team up. Yeah, okay. I'll team up with someone as we go along. Okay. So let's say Susan. Is Susan there? Let's see if Susan's
I'm
here.
here.
Okay. Do you know anyone that you'd like to work with in your lab group?
No, I don't.
Okay, so what about I? team you up with Mirage. Is that okay?
Yep, that's fine.
Okay, so you're group 2. Okay, you're both group 2. Number 2. Mikara. Okay, are you there, Mikara? Let's see. I don't see Mikara here. So far, I'm gonna put group 0, right? Ryan, are you there, Ryan? I don't see Ryan here either. Okay, so let's put it here, 0. Evelyn Ayala, are you there, Evelyn?
Yeah, I'm here.
Okay, do you know anyone that you'd like to work with, Evelyn?
No.
Okay, so as we go along, I will see who I can team you up with, okay? Let's see. Next is Cristina Balderas.
I'm here.
Okay, do you know anyone you'd like to work with, Christina?
No, I don't.
Okay, would like to team up with Evelyn?
Okay.
Okay, so here you go. You're both group number 3. Ben Bandoy, are you there, Ben? I see Ben here, but I don't hear him answer. I'm gonna put a star in Ben's name. I'm gonna put for him for now with group 0, right? Queen Castaneda.
Hello.
Hello. Okay, do you know anyone you'd like to work with, Queen?
Yes. Emily?
Emily? Okay, Emily Serna, right?
Yes.
Okay, so let's put here Emily. Emily, are you there?
Hi, yes, I'm here.
Okay, good. So you already have a group. Okay, Isabella Cisnero.
I'm here.
Okay, do you know anyone you'd like to work with, Isabella?
No, I don't.
Okay, so you're gonna be group number 5 for now, and as I move along here, I will see who I can team you up with. Okay, Luis Diego Cruz. I don't see Luis. Yeah, I don't see Luis. Next, Delisha. Oh, Delisha already have a group, right? Okay. Gabriela Edwards.
Hi.
Hello,
I don't have a
Gabriela. Are
group.
you there?
Yes.
Okay, good. Do you already have anybody that you'd like to be in your group?
No.
No? Would like to team up with Isabella?
Yeah, that's good.
Okay. So start to exchange email addresses, right? Contact information among each other, right? So let's go to Princess now.
Well,
Hello, Princess. Do you know anybody that you'd like to team up with?
yes.
Who is that?
Kimberly
Kimberly. What's her last name?
Morales.
Morales. Kimberly here, right? Okay, 6.
Yeah.
Okay, good. So you already have a group. That's good. Let's go for Carlo Gallardo. Is Carlo here? I see. Looks like he is here. Can you hear me, Carlo? Looks like Carlo is away from his computer. Next is Trin. Hello, Trin. Are you there? Okay, good. Do you already have anyone that you'd like to team up with? No? Okay, so I'm gonna put you group number 7. And as we move along, I will find someone to team you up with, okay? Let's see, next. Steven.
I'm here.
Okay, do you already have anybody for your group, Stephen? Stephen,
No.
right? Stefan?
Yeah.
No?
Yeah. No.
Okay, would like to team up with Stream?
Sure.
Okay, so go ahead, exchange contact information between each other. Jeremy Landis. Are you there, John? Okay, okay, good. Do you already have anyone that you'd like to team up with, Jeremy? Nope. Okay, I'm gonna put you in group number 8, and let's see who we can get you. Who else I can get you in your group? Paola, are you there? Okay. Do you already have anybody that you'd like to be in your group, Paola? No? Okay. So would you like to team up with Jeremy? Okay, good. Your group number 8. Pedro Lopez.
Here,
Pedro.
Professor.
Okay. Do you already have a group member?
No, I don't.
Don't? Okay, so I'll put you group number 9, and let's see who I can team you up with. Okay, Janie Marisol Maldonado. Janie. I don't see Janie here. Janie is not here, right? So let me put 0 and 0. Noemi Martinez. I don't see Noemi here. Okay, 0 and 0. Isabel Medina. Hello, Isabel. Looks like Isabel is away from her computer. Kimberly Morales. Okay, Kimberly is here, right, Kimberly?
Yeah, I'm here.
Okay, good. So you already have a group. Ramon Moran. Hello, Ramon. Are you there? Looks like Ramon is away from his computer. Next, Arian Navidias.
Professor, I think you
I'm
missed
here, Professor.
me,
What's your name?
Isabel.
Isabel? Okay, Isabel. What's your last name?
Medina.
Medina. Let's see. Right in here. Okay, good. So you're here, right? And let's see. Do you already have someone that you'd like to team up with, Isabel?
No.
No? Okay, so Medina, I'm gonna put you in group number 8 for now, and let's see who can join you, okay? Arian is here, right?
Yes.
Do you already have anybody for your group,
No.
Arian? No? Would you like to join Medina, right? Wait a minute, I'm getting lost here.
Number 23.
23.
Medina.
Isabel. Okay. So, okay, it's not 8, right? It's supposed to be. Okay, let's see. It's Pedro,
10.
right? It's Pedro who doesn't have a group yet. Okay, Pedro. Isabel, would like to join Pedro in the group?
Sure.
Okay, so here you go. Now, I'm talking to Arian right now, right? So you're going to be group number 10, Arian.
Yeah.
And Oni is here, right? She already has a group.
Yes, I'm here.
Okay, good. So you already have a group. Let's see, Mario Ochoa. Hello, Mario. I don't see Mario here. 0 and 0. Ahmad Olumi. I don't see Ahmad either. Next, Arwa Paris.
I'm here.
Okay, do you have a group member?
No.
No? Okay, so you're going to be, would like to join Arian Avidis?
Sure.
Huh? Okay. Okay, Dana, Oni already has a group, okay, Dana, so I have to put you in a I need to put you in a different group, okay? Okay, so next is Catherine Michelle Perez. Okay, you are here. Do you know anybody that you'd like to be in your group, Catherine? No? Okay, so you're gonna be group number 11 for now. Nadia?
I'm here.
Okay, do you know anybody that would like to be in your group, Nadia?
No.
No? Okay, what about you team up with Catherine, okay?
Yeah.
11, okay. Tatiana? Let's see if Tatiana is here. I don't see Tatiana. Next is Steve Sanchez. I don't see Steve Sanchez either. Okay. Good. Next is going to be Jason. Are you there, Jason?
Hello, yes, I'm here.
Okay. Do you know anyone that you'd like to team up with?
Anyone is fine.
Anyone is fine. Okay, so I'm going to put you in group 12 for now.
Okay, thank you.
Okay. Let's see. Francesca Sorrentino. Let's see here. Ramon Moran, right? Let's see. Ramon return here. Yeah, okay, Ramon. Thank you for letting me know. Do you know anyone that you'd like to be in your group, Ramon? Yeah, Ramon is not answering. Okay. So let's go Francesca, right? Francesca is here. No, Francesca is not here. Chris Anthony. I don't see Chris either. Dana. Okay, Dana is here, right? So do you know anybody else, Dana, that you'd like to be in your group? No? Okay, so you would be, what about you team up with Jason Cervellon? Is that okay? Okay, okay, so exchange your contact information. Good. And Audrey?
I'm here.
Okay, do you know anyone in the class that you'd like to team up with, Audrey?
No.
No? Okay, I'll put you in group 13. Let's see, Juan Torres Arellano. Is Juan here? I don't see Juan. Okay, so now what about that other student? Ramon, are you there, Ramon? Okay, so why don't you team up with Audrey, okay, Ramon? Okay, Audrey? Why don't you team up with Ramon?
Sounds good.
Here, group 13. And here is going to be 0. Okay, so looks like we did everything here. Let's see how many students we have today. Okay, good. Okay, we can go for a break now. And when we return, I will give you a link to your group folder. Okay, and go here in my notes, this one. Let's break. That's 11, right? Yeah, 11 to, let's see, 11:26 a.m. Yeah. Okay. So I will see you in 15 minutes. I am back here. Okay, there is Steven, right? Steven, you need you want to assign, you want a group assigned to you, right? Let's get Steven here. Steven is here. Do you know anyone that you like to be in the that would like to be in your group, Steven? Steve? Okay, you do not know anyone. Let's see. I think. Okay, let me put you for now in group number 14, and I'll find someone. Yeah, if I find someone to team up with you, I will let you know. Okay. Does everybody has a group? Does everybody has a group? Let's see. Who does not have a group? Everybody has a group, right? Okay. So 27, 13, Steve, 14. Okay. Okay, for now, I'll keep. Oh, you don't have a group, Carlo Gallardo, right? Let's see here. Carlo Gallardo. Yeah, okay. Why don't you join Steve? Okay. Steve Sanchez, right? Unless you have someone else, unless you have someone else that you like to team up. Okay, I'll put you on group number 14. The other student that I saw here, Ben, are you there? Ben Bandoy. Okay, Ben must be away from his computer. It says, okay. Okay, so it looks like everybody has a group with the exception of Ben. Okay, and Carlo and Steve exchange, contact information. And what we're going to do next, we have a total of 14 groups, right? What we're going to do next, I'm going to give you a link for a group folder. Okay, you're going to be using this group folder for the rest of the semester. And let me go here to the group folder is going to be my Google Drive. It takes some time to set up that stuff, okay? So let's go here. 2026. Okay. Physics 07. And then I'm going to come up with all sorts of group 1. Group number 1. Let me prepare that first. New folder, group number 2. Group number 3. Group number 4. Group number 5. Group number 6. Group number 7. That's going to be the folder that you folks are going to use for the lab. I have been using my Google Drive for several years already. It works very well. I once tried to use Canvas, but it didn't work well. That doesn't look like Canvas is well prepared for this type of activity that we do here. So the way it's going to be is the following, folks. Every lab, you will be provided a spreadsheet, and you will work on this spreadsheet. The spreadsheet is going to be different for each group. Okay, and your spreadsheet, your Excel spreadsheet is going to be available there in this group folder of yours. And you're going to work on the spreadsheet. And then once you are done working with the spreadsheet, you upload the work at the spreadsheet to your group folder. Okay, that's how we do it. I tried to do that in Canvas and it didn't work. Well, so I'm going back to the group folder here in Canvas. And now what I'm going to do, I'm going to provide a link for each of those group folders. Okay. So here you go. Let's start with group number 1. And let's see here. Let's see here. Group number. Can only 2, Steve. Only 2 people. But you already teamed up with someone, right? Who are you teamed up? You're teamed up with Carlos Gallardo, right? No, Ben didn't answer. So yeah, I teamed you up with Carlos Gallardo, okay? Now who's coming? Noemi? Let's see. Noemi just joined us. Let's see, Noemi. Noemi Martinez. Are you there, Noemi? Okay, so let me give you attendance here. And do you know anyone in the class that you would like to work with in the lab? Noemi? No? Okay, I'm gonna put you in group number 15 for now. Okay, right now I do not have anyone to team you up with. But once I get someone, I will assign you to this other person. Okay, Noemi? Okay, so we need one more group folder here. And let's see how I'm gonna do that. Has to be very organized, right? So let's see. One more. Oops. So far is a total of 15 groups. Link. Each group is going to have a different link for those folders. And let's see, I'm gonna share, copy the link. Why it's not, let's see here, share. Restricted, anyone who's the link, copy the link. I will copy the link and very soon I will send the link to you, okay? Share. Copy the link. Anyone with the link, I copy the link. That's group number 2. Oh, wait a minute. There's something wrong here. It's not viewer, it's editor. Done. Let's see this one too. Not viewer, is editor. Okay. Done. Group 3. Anyone with the link? Anyone with the link? Let's see if I can do everything at once, right? Anyone with the link? Everybody will be editor. I didn't know we had this choice here in the. That's nice. Okay, now how do I copy the links? Links copied, yeah, but which one is which, right? Oh, interesting. Share, copy the link. Okay. Okay. Copy the link. Copy the link number 4. Number 5. The link. Now 6, 7, 8, 9, 10, 11, 12. Okay, now let's see here. Share. Okay. Anyone is the link? Viewer, everybody's an editor. That's good. Let's see. Number 6. It's not in numerical order. Huh? Okay, done. Now, interesting. I didn't know about this thing that we could do. Copy the link 7. Copy the link 8. Copy the link 9. Copy the link 10. Well, getting almost there to email you all. 40. 50. Good. Now, let's start. Group number 1. Let's see, who is group number 1? Let me go. Sort by group number. Okay, Delisha and Oni, right? I'm going to
Yes.
send you your group link. Don't share this group link with anyone, okay, Oni? Share just with Delisha, just with your group members. Delisha is not here, right? So let's see how I can do that. Oni.
Okay.
Let's see. Okay, that's your link for your group folder. Keep it in a safe place and share that with your group member, the Leisha. Okay, that's group number 1. Group number 2 is Mirage and Susan.
Right here.
Okay, Mirage. That's your group. That's the link for your group folder, Mirage. Are you there? And
Yes, I'm right here.
Let's see. Very soon we are going to work on that. So you are Susan. I'm sending the link to your group folder as well. That's group number 2. Group number 3. Let's see. Who is group number 3? Is Evelyn and Christina. Evelyn, here is the link for your group folder. Christina. Christina, here's your link to your group folder. Next gonna be group number 4. Queen and Emily. Emily. Here's the link for your group folder, Emily. Here's the link for your group folder, Queen. And again, don't share this link with anybody else, just with your group members. Now, group number 5. Isabella Cisnero and Gabriela. Isabella and Gabriela. Looks like Isabella left, right? And where's Gabriela? Gabriela is here. Okay, Gabriela, that's your link for your group folder. Share that with your group member, okay? Group number 5. Group number 6 now. Princess and Kimberly. Princess.
Yes.
Here's the link for your group folder, Princess. With the other one, Kimberly. I have a message here. Let's see who's that. Okay. Good. So next, that's group number 6. Let's go for group number 7. Trin and Stefan. So Trin. Stefan. Okay, so confirm that you all have got your links. Next, group number 8, Jeremy and Paola. Group number 8. I don't see Jeremy here. Looks like Jeremy left. Paola. Paola, this is the link to your group folder. Okay, thank you. Anybody else? Okay, next, group number 9. Group number 9 is Pedro Lopez and Isabel Medina. Pedro Lopez and Isabel Medina. Steve Sanchez, right? Okay, we're gonna get there. I'm gonna, I'm showing group number 9, okay, Steven? Steve, I'm showing group number 9. I'll get to you soon. Let's go group number 10 now. Arian and Awa. Arian and Awa.
Yes.
Okay, here you go. I sent your links, right? The links to our group folder. Group number 10. Now, let's go for group number 11. It takes some time to do that, right? Because I gotta do that one by one. There is no automated way of doing that. Catherine and Nadia. Number 11. Nadia. And then we're gonna test all those links to make sure everything works fine. Group number 12 is Jason and Dana.
Yes.
Okay, I'll get that. Jason first. You go, Dana. Then you go. Group number 13. Ramon and Audrey.
Yes.
Let's see. Ramon. I don't see Ramon here. Okay, Audrey.
I'm
Audrey is
here.
here. Yeah, Audrey is here. So share this link with your group member, Audrey, please.
Okay.
Group 14, Carlo and Steve Sanchez. Carlo Gallardo and Steve. Here you go. And last but not least, your lab number Noemi, right? Noemi Martinez. You still do not have a partner for your group. So I hope you all got your links. If you didn't, let me know. Thank you. Let's see, one more. And then I had to step away for a bit. Okay, which group? Okay, here you go. Why don't you join Noemi? Okay, Noemi Martinez. Ben. Let's see here, Ben Bandoy. Group number 15. Okay. Okay. So share the link that I sent to you, Noemi, with Ben, please. Now we have set up who does not have the link for your group folder? let me know, okay? We still have a bunch of students here. We have 10 students, 10 more students that didn't show up today. Right, those 10 students, they don't have a group and they don't have a link either. Okay, so we are going to go through some simple exercises here to make sure you have the right link, to make sure you know how to use, also how to upload and download files to the group folder. Okay, so what we're going to do. Here you go. First thing, one, I want you to get any file that is in your computer, okay, comma, put your name, put your last and first name in the file and upload it. Upload this file to your group folder. How do you do that? Click, drag, and drop. Okay, can you do that? That's the first exercise that you're going to do. Okay, and once you are, oh no, wait a minute. There's something easier that we can do. Before we do that, click the link, okay? And make sure that you are inside your correct group folder, okay? That's the first thing that you're supposed to do. That's much easier than the next item here. So once you, here you go. Once you get, I'm gonna, for instance, click the link here of group number 1, right? And then what happens? Here you go. I am in, see the group number 1. So if you belong to group number 1 and you click the link that I sent to you, you are supposed to see group number 1 here at the top. If you don't see group number 1, if you see a different group number than the group of yours, let me know. Okay, let me know. If you see a group number that's not yours, that's because I sent you the incorrect link. Okay, I don't think I did, but So here you go. So that's your first task. Very simple one. Just click the link. I'm gonna click the link here of group number 2. When I click the link of group number 2, I am supposed to end up in the folder of group number 2, right? And so on. Just make sure that you got the correct link for your group folder. Right, and keep this link in a safe place for the rest of the semester. One more here. Here you go. Keep the link of your group folder in a safe place for the rest of this semester. You'll be using this link for the remaining of the semester. Click the link and make sure you click the link of your group folder, and make sure that you're inside the click the link I provided you. Let's put it this way. I provided you, and make sure that this link takes you inside your correct group folder. Any problems so far? Did you get the right link? Let me ask you one by one, right? Not everybody, but just one. I'm gonna just pick up someone here by random. Here you go. Christina, is the link that I provide you the correct one?
Yeah, it is.
Group number 3, right?
Yeah.
Okay, good. Let me pick up someone else here. Stefan, your group number 7. Does your link takes you to the group number 7 folder? Can
Yes.
Okay, good. Ben Bandoy. Okay, good. Let me, no problem. Right or about group number 12, Dana Terry. Do you have any problems there with your link?
No.
Okay, good. Okay, so no problem. So let's go for the next exercise, right? Get any file that is in your computer, in the hard drive that is in the hard drive of your computer, and write your name in this file and upload it to your group folder. Let's make sure it works. I should see 2 folders, two documents that are inside your folder, right? Click, drag and drop, right? Click, drag and drop. Let me do that myself so you understand what I mean. Here you go. Let me get any file that I have here in my computer. Let's see. Make sure I don't share anything confidential with you folks. Let's see, what about that? Okay. So I am going, okay, I'm gonna use this one here. I'm gonna put my name, okay, Claudio Egalon. See, I'm here in my desktop. Click this file. What happened? It disappeared. Let's see. Must have the. Uh-oh. What happened? Wow.
It
What
went
happened?
to the top of the page, Professor. It went to the
What?
top of the page.
Top of what?
Yeah, you see recycle bin, Microsoft Edge, delete folder is the 4th one.
The 4th one. Let's see. Are
Yeah,
you talking
to
about
the,
the recycle bin or?
no,
Oh, this one
no.
here.
Yeah, yeah.
Okay, this one here. Why did it end up there? My God. Never seen anything like that happening. Okay, so, click, right? Drag and drop. And here you go. I'm dropping here to group number 1, right? And then once I open group number 1, my file is supposed to be there. Okay? So I want you to do the same, just to make sure everything is working fine. And then I will ask you to delete, move to trash, just like I did. Okay? I want everybody to do that. I want to see 2 documents there inside, one from each student. So I know that it's working. Okay. Group number 1, no. Group number 2, no. Group number 3, yeah, I see. I see someone, but I don't see the name of the person in the file name. Let's see. New folder, how's this? View type, people modified. Is that the one? List layout, okay. Christina, here you go. That's Christina. So Christina successfully uploaded her file. I want to see everybody else uploading their file. Emily and Queen, okay. That's group number 4. Emily, good. Let's go for group number 5. Gabriela, right? Gabriela managed to upload her file. Let's go group number 6. Kimberly and Princess. Group number 6, yeah. Kimberly and Princess, good. Group number 7. Trin and Stefan. Yeah, Trin and Stefan, that's good. Group number 8. Okay, nobody uploaded any files to group number 8 yet. Group number 9, I don't see any files in group number 9. Group number 7, Adrian. Adrian, right? Adrian managed to upload. Group number 10, good. Our student upload. Group number 11, Nadia. Nadia is group number 11, that's good. I wanna see Catherine Michelle's file there inside as well. Jason, group number 12. Let's go group number 12. Jason Cervellon, okay. And Dana, I want to see your file there as well. Let's see. Group number 13. Audrey. Audrey posted her file, but Ramon still didn't do it. Group number 14. Carlo Gallardo and Steve Sanchez, right? Carlo Gallardo and Steve Sanchez. And group number 15. Ben Bendoy, I see. Noemi, did you manage to upload your file? Noemi still didn't upload, right? Let's see. Someone sent, check my group number 2. Okay, Susan, I will. Let's start from group number 1 all over again. Here you go. Nobody in group number 1, nobody uploaded the file yet in group number 1. Let's see group number 2 now. Okay, Acosta. Acosta is Susan. Okay, Susan uploaded, but Mirage still didn't upload it. Evelyn. Let's go group number 3. Okay, Christina and Evelyn. Christina and Evelyn. Good. Both students. Group number 4. Emily and Queen. Yeah. We go. Next is group number 5. Just Gabriela uploaded. Group number 6. Princess and Kimberly. Okay. Group number 7. Trin and Stefan. Group number 8. I'm doing that all over again because I didn't write down who. Okay, who had uploaded file. Okay. Group number 9. Pedro Lopez. Pedro Lopez and Isabel Medina. Make sure you upload your file there as well. Group number 10. Arian and Awa. Okay. Arian. Awa. Group number 11. Catherine. Okay, Catherine, you created a folder, right? You see that? You didn't upload the file from your computer. You just did something like that, just click new folder. Okay, make sure you get a file, an actual file from your computer and upload right in here. Nadia group number 11. Okay, here you go. And group number 12, Jason and Dana. Okay, Jason and Dana. Group number 13, Audrey. Audrey, yeah. Group number 14, Carlo. Oh, we have 3 different. Okay, Steve and Carlo. Okay, good. Group number 14. Good. So not everybody uploaded, right? A file there. But you have plenty of time to find out how to do that. The whole semester. It's not difficult. Let's see, Steve here. I was able to upload the document to group 14. Okay, Steve, thank you. Let's see, Pedro Lopez. What about Pedro? I just posted a file for group 9. Okay. Pedro Lopez, group 9. Yeah, okay. Okay, so group number is Oni there?
Yes.
Okay, were you able to upload your file, Oni?
You want us to upload the file?
Yeah, any file that's in your computer. You can create any document there. It can be a blank document. Write down your name there. And then once you do that, click drag and drop. That's all you have to do. Okay, so you can practice how to upload your documents to the group folder. Okay. Okay, so like I said, you're gonna have plenty of time to practice that as we move throughout the semester. The last thing I want you to do is to delete those files that you uploaded. Okay, that's straightforward. All you have to do is go inside your file, click it, right click it, and then you remove. Okay, can you do that just to practice? Okay, here you go. Group number 2 did it, right? Delete it. Let's see, group number 3. Yeah, group number 3 still didn't delete it. Group number 4. Let's see, group number 4. Only Queen, right? Only just Queen deleted. Okay. Oh, Queen.
I just removed them right now.
Emily also deleted, right? Here you go. Thank you, Emily. 5. So that's Gabriella's file. Hi, Gabriella. Delete your file, please, so you know how to do that. Let's go to group number 6.
Excuse
What
me,
time is
Professor.
that? Should be time for a break, right? Yeah. Okay, so let's have
Excuse
our
me,
break.
Professor.
Yeah?
Yeah, so I just dragged and dropped it in the folder, but for some reason it's not working.
Okay, who is that? Who is that?
My name is Mirage.
Mirad. Okay, you're group number 1, right?
2.
No, you're group number 2. Okay, so let me see if I have any problems. Okay, I'm gonna do that on my side here. Your group number
My
2.
teammate did it, but I don't know why.
Is your link working? Make sure your link is working. Is your link working?
Yeah, I'm in right now.
Okay. So
Do
your
I
link
need to sign in or anything?
all you have to do is to click the link. That's all. You
Yes,
don't
the
have to
link is
sign.
perfectly working. And I
Okay, the
just
link.
dragged and
Click, drag, and drop.
yeah, this is exactly what I did.
Okay, so I'm gonna do it here in my computer. Okay, I click the file with my name. I'm dragging to your folder, right? Here you go, and I dropped. It's uploading. Yeah, see, my name appeared in there. So if you cannot do it, maybe there's a problem with your internet connection there, okay?
Maybe.
You can try later on too. If you cannot do that now, you can try later on as well. Sometimes it's just a
I'm
bug
gonna
that,
play with it. Once I succeed, I will let you know. Is that
play a
good?
little bit. Play a little bit with that. Let me delete this one, move to trash. It should work well. And 12:12 right now. Let's go for our break, right? Well, we have done a lot, right? Let's see here. After doing that, after uploading your file, delete it from your folder. Okay. And now I want to get into the
So
break.
that
Yeah.
oh, I have a question. Sorry. So that is just for practice, or?
Yeah, just for practice. I would just for practice and also to make sure that the link is working fine and you know how to do it, right? Every now and then I find some students that have never done things like that. Okay, so
Yeah. Okay. And those are just for reports, right?
you'll be doing that during the whole semester. Yeah, for the reports for the spreadsheet that you're going to be working on.
Okay. Thank you.
Okay, and a very important message here too. Okay, there are the joys and the pains of working in group, right? Let's be upfront about that, right? Sometimes you get a very good group member that helps you out. You two works together. Sometimes there are sometimes you have to find the right person to work with you in a group. Okay, it does happen with a great deal of frequency that for some reason someone that you're working with it doesn't click. Sometimes you don't work together, don't work well together, and so it may happen. Okay, it may happen. Don't and sometimes it's just the other group member that does not do anything to help out, right? So I want you to warn you about that. Okay, those things, they do happen. It's part of the life in work as a team. Okay, classmates, you're gonna find classmates that is not gonna work well with you. You're gonna find even colleagues at work that don't work well with you, and then it may happen in the lab report as well. Okay, I just want to mention that to you. If something comes to that, and if you prefer to work alone or if you would like to change group, just let me know. Okay. So it's 12:15 p.m. right now. Let's gonna have another break from 12:15 to 12:30 p.m. And then we will continue with this so-called lab. Okay. I see you in 15 minutes. I'm back here. Okay, so let's see. Now it's 12:30. You have 20 more minutes to go here. I think I did everything that I want to do for the lab. And for the actual lab that we are going to do next week, we will have to cover some material so you can understand the lab, how the lab is done, right? So let's take a look here. Today is Wednesday. Next Monday is going to be a holiday. So we're going to take time off. And then next Wednesday, we will do the actual first lab. But before we do that, I want to cover a little bit of the material that we are going to need for the actual lab, which is first the electric field. Okay, let's talk about the electric field. And we talked about, here you go, what did you, we talked so far, we talked about the following. One, the core idea that we are going to be using it throughout the whole semester is that idea, is the concept of electric charge. Okay? That's the basic foundation of electricity and magnetism. If you don't understand what an electric charge is, if you don't have a clue of an electric charge is, you won't be able to understand this material. So you have to have this abstract, the picture of this abstract idea of what an electric charge is. It's something intrinsic to matter. Electric charge is something intrinsic to matter, as the mass is too, right? Mass is a property of matter. So electric charge is also a property of matter, distinct from mass. Okay? Keep this idea in your mind. Electric charge can be either positive, negative, or neutral, 3 types of charge. What else did we talk about? We talked about the electric force. Okay? Charges, electric charges, they exert forces between each other. If a charge is neutral, though, no electric force is exerted on this charge. Okay? So, and that's what Coulomb's law is all about. Coulomb's law is all about. A force, here you go, a force is vectorial in nature, right? So we talked about forces in physics 6. So here we have also a force. It behaves exactly like the other forces. It is a vectorial quantity. Okay, if let me give you an example here. Let's see here. Oh, here you go. We have a set. Suppose that we have a set of electric charges, right? Here you go. Q1, Q2, right? And I'm going to place another charge, Q3. They're all lined up. And I want to know the force applied to Q1. What I showed right in here is just the force that 2 applies on the charge 1, right? That's what this notation is all about. Force of 2 applied to charge 1. But because we have this charge 3 will also apply a force on charge 1. Charge 2 is applying a force to the right. Charge 3 is applying a force to the left because it's a charge with the same sign. So f of 3 in 1 is going to cancel part of f of 2 in 1. Okay? Those forces are being summed up along a line in this case. But we can have some other things that are more complicated than that. Okay, here goes. That would be my net force applied to 1. The vectorial summation of those 2 charges, of those 2 forces. Okay? Catherine is trying to get, here you go. Here's the model of the atom, right? In the case of the model of the atom, you have a nucleus that has positive charge, that has a positive charge. Inside the nucleus, we have protons of positive charges and neutrons of neutral charge. And we have electrons orbiting around the nucleus. This is a very good model for you to understand how an atom is put together. Okay? Now let's take a look at other situations in which we have an electrostatic force, an electric force acting in a charge. Okay, so here you go. Consider the X and Y axis, the two-dimensional axis. We have a charge that I place right in here at the origin of the axis. This charge is fixed, it's not moving whatsoever. And then I'm gonna put other charge at different places. We have this charge Q2, that's a negative charge that's placed along the x-axis, and I'm gonna place another charge Q3 along the y-axis. Because Q3 is positive, the force between Q1 and Q3 is going to be repulsive. Okay? So here you go. We can come up with the forces being applied in charge number 1. This is a repulsive force, F31. F of 3 applied to 1. That's what F31 means. And then we are going to have the force of 2 applied to charge 1. Okay? All those charges are at rest. All those charges are fixed in place. So imagine that I got a nail and bang, right? Put them at rest there at that specific spot. They are not moving. All those 3 charges are fixed. Even though they are fixed, they still have those electric forces acting on the surrounding, on their surrounding. Okay, in this specific case, I am saying that force of 2 acting in 1 is larger than force of 3 acting in 1. Why is that? That's because charge Q3 is further away. Okay, it's further away. That's why I am assuming that is weaker. So the net force applied, we just use the summation of forces, okay, is going to be this net force that you see right in here. Gonna be the vectorial summation of those 2 forces, sideways to the bottom, right? Let me see, pointing in the southeast direction. If up is north, down is south, right is east, left is west. We say that should be even east of southwest, east of southeast direction. That would be the direction. Here's the angle theta. And just like in physics 6, we can calculate what this angle is going to be. This angle is going to be the magnitude. The tangent of the angle theta is going to be the magnitude of force F31 divided by force F21, right? And then we can have variations of the situation. Instead of the charges located at the x and y axis, we can displace the charge number 3, for instance. Charge number 3 can be a little bit to the right. Huh? Make sense? And now, force of 3 in 1 is going to be at an angle slightly off, right? That's something you can do just by drawing. Let's look at another example. Here you go. So here goes. We have those 2 charges, Q1 and Q2. They are equidistant from the origin. Okay, the distance is the same. Okay, what we see here is isosceles triangle. That's what we see here. This distance is the same as this distance. Right? This distance is the same as this. And this positive charge is exactly at the middle here. And then what we have? We have a repulsive force along this line and another repulsive force along this line. And those 2 vectorial forces, are going to sum up each other and gonna result in another net force. It's gonna be somewhere along this direction, right? Something like that we have. Can you picture that? most of this course, a big part of this course would be to visualize these types of forces, not just this vectorial force, but other types of vectors as well. You have to have a picture, a mind picture of this type of vectors. Let's take a look at another example. Here you go. Now I have 1, 2, 3, 4 charges. They're all fixed in space. They're all fixed in space. And all those 3 charges are acting on this 4 charge. Okay? Because those 2 charges have the same sign, the force is going to be repulsive. And also, they all have negative charges. So all the forces present are going to be repulsive forces. And the net force is going to be the vectorial summation of those forces, right? So let's do that together. Here you go. I'm going to repeat this graph here. They all have the same charge magnitude. Okay. It's an electron, right? Minus Q, minus Q. So what's gonna have, this charge has the same magnitude as this one. The distance is the same. Consequently, the magnitude of this force is going to be the same magnitude as this one here. The net force between those 2 forces is going to be something like, let me get a parallelogram here. Let's see if I can get that. Like that. No, I don't want that. I want something else. Here you go. That's what I want. Like that. 6 more minutes to go. I want to take advantage of all the time we have available here. Let's see, this one here that I want. Let's see if I can get this guy properly. Yeah, I got it. See that? I'm going to come up with a parallelogram method, with a parallelogram. Here you go. Let's see if I managed to do that. Here you go. Okay, and now I'm going to switch like that. If I did everything right, yeah, it doesn't look like I did everything right, huh? Yeah, I didn't do everything right because this distance is not exactly the same one. But because, if I had done everything right, the resulting vector due to those 2 point particles alone would have been this one right in here. Let's make it thicker. Yeah, and I'm gonna put it a different color. No, I don't like this color. Or about this color here, okay? So this green vector is the summation of those 2 vectors, okay? It's the summation of those 2 vectors. And so this green vector here is gonna cancel out a little bit of this force that you have coming from this other particle right in here. 5 more minutes. Okay, so that's what I want to talk about forces, right? Let's write that down. Electric force. Electric force behaves just like any force. Behaves just like any force. It is a vector. Every force is a vector, okay? So the vectorial summation applies when you have multiple charges exerting forces among each other. Okay? That's the idea you have to have in mind. And then what's next? What's next in line? After the electric force, we have what we call an electric field. Okay? So here you go. Let's repeat. What's the progression here? 1, electric charge. Even better, I'm gonna put like that. Electric charge, force, and after force we have field. And after field we have potential energy. Remember? We saw that in physics 6, right? And after potential energy, we have something that we do not have in physics 6. We have, don't forget, electric charge, electric force, electric field, electrical potential energy, and then we have something else that we didn't cover in physics 6, which is the electric potential, okay? And I want to change, let's see how I'm gonna do that. No. Yeah, that's what I want to do. Let's do that this way. Okay? Do you get the idea? Okay. Let's see here. Paragraph. I want to single. Good. Okay, now we have a better way. That is electric charge, electric force, electric field. We are right here. We're going to talk about the electric field. One more minute to go. I won't have much time to talk about that. Yeah, okay. We'll talk about the electric field next time that we meet on Wednesday, okay? And that we will also need to talk about the electric potential energy and the electric potential before we start the lab. Okay? So in this meantime, try to remember, refresh your mind about the idea of gravitational potential energy, right? That we had before in physics 6, because there is a close parallel between the electric potential energy and the gravitational potential energy. The only thing that's going to be new here for us in electricity is going to be the electric potential. Okay, we do not have, it's not that you don't have, we did not cover the gravitational potential. We didn't cover explicitly, but in reality, the gravitational potential is nothing more than the acceleration of gravity, the vector acceleration of gravity, okay? So that's the, that's the parallel between electricity and mechanics, okay? In the case of electric charge, the parallel with mechanics is going to be the mass, okay? An electric force is going to be versus the gravitational force. Gravitational force. And the electric field is related to the acceleration of gravity. Okay, the electric potential energy is related to the gravitational potential energy, which is going to be mgh, right? And what else? mgh is going to be gmm squared. No, divided by d. No, gmmd. Okay, that's going to be the gravitational potential energy. And the electric potential, what is is going to be versus the electric field. Yeah, we do not have a parallel. We can, let's see, we can define a gravitational potential, yes. But I'll talk about that when we meet again on Wednesday. It's already 12:52. We are past the time. Okay, and then we can stop right now. I will upload everything that I did here today. Okay? See you 1 week from now.
Thank you.
Welcome.
Thank you.
Welcome.
Thank you,
Professor.
Have a good night.
See you.
Excuse me, Professor. I have a question.
Yeah, go ahead.
My question is, um, will you upload some things on the? You said the lab. You said the Google Drive thing, like bec- because I don't know how your class works. So, will you upload things on the Google Drive? Then we will see it there, or will you give us notification when?
Yeah, I will upload to the Google Drive. So next Wednesday when we start our lab, I will do that. And I will walk you through so you can become familiar how we do that step by step. Okay, I'll give you enough time for you to understand how I do the lab. Okay.
Okay.
Plenty of opportunity for you to get familiar to the way with the way that we do these labs. Okay.
Okay, and I also finished the assignments on the Wisely Plus website.
Yeah.
Like, yeah, is that all the assignments, right?
Yeah.
From where?
For now, we have only 2 assignments, but there will be more that I'm
Okay,
going to post. Okay. For now, you have two assignments for 2 different chapters. You can start working on them. There will be more as we move along.
okay. Thank you.
Welcome.
All right, bye.
See you. Let's see here.